A very warm welcome to this webinar about the history of wind power, which is co-hosted by the World Wind Energy Association together with the Mills Archive Trust. My name, many of you may know me, is Stefan Xenger. I'm Secretary General of the World Wind Energy Association, and I will moderate this, I believe, really exciting webinar about the history of wind power. And it's my pleasure that we have here colleagues from around the world already at this moment. I'd like, before we start, first ask you to be aware that this is a public event. So after the recordings will be published in our YouTube channel. So whenever you show your face, whenever you say something, then please be aware it's public and in principle everyone can see you or can hear what you say. I would request everyone to stay muted until you are requested to speak. We have 3 or 4 speakers today, and of course, we will give the opportunity to everyone to also ask questions, add comments. We are looking forward to additional insights that some of you might have. Today we have discussed how to describe the history of wind power, not windmills, but wind power. And we've come to the conclusion that it makes sense to kind of subdivide modern history. The first period from the year, at the moment, 1883. This is now the first time that we know there are records available when a windmill was connected with a generator in Vienna. Then until kind of around the First World War, second period from end of the First World War till around 1970, and the third period after the year 1970. Yeah, with this, it's my pleasure to also introduce our co-host, Elizabeth Bartram. We may also call you Liz, and I'd like to maybe invite you to also welcome our participants.
Yes, thank you. Thank you so much for the opportunity. So I'm sort of wearing a more sort of historical hat, if you like. So I come from the Mills Archive Trust, and we cover the history of milling, wind and water power going way back. So we look at the really old stuff before electricity generation. But in recent years, we've sort of incorporated electricity generation as well. So that's kind of the slant that I'll be putting on this today. But it's a great opportunity to speak to people who are also interested in the modern side of things as well, because we're trying to sort of join the two together, the past and the present. So yeah, great. I'm very happy to be here.
Yeah, thank you very much, Liz. With this, I think we are now ready to really start with our presentations, and you now will start with the first period, as we talked about it, starting, in the 19th century, speaking about the first and early pioneers. So, Liz, the floor is again yours, and I'm looking forward to hearing from you and also seeing maybe some pictures.
Yep, thank you very much. I've definitely got pictures. So let's just make sure that I share the right screen. Can you all see that? Hopefully, great. Okay. I love this picture of this man who I'll be introducing a bit later. So yeah, so as Stefan very kindly said, I'll be sort of focusing on the period of the 1880s up to about the First World War. But with the caveat that I'll actually be trying to put this into context by looking at some of the earlier history as well. And what I will also do, if you don't mind, is also give you all a bit of an introduction to the organisation that I work for and show you some pictures of the sorts of things that we have. There is someone that I will also mention towards the end who's actually after the First World War, but he's someone who's very close to our hearts at the archive, so I hope you don't mind sort of indulging me. This montage, if you like, at the bottom of the slide was made by one of my colleagues, Nathaniel, our archivist, and all of these images are from the Mills Archive Trust. So what we're trying to show here is the ancient post mill, how the windmill went through periods of development, and then obviously we're extending it up to wind turbines of the present day as well. So the Mills Archive Trust, some of you might have heard of us already. I do recognise some of the names and faces in this call. We're an educational charity. We're completely independent, so we have to raise all of our money ourselves, and we've been going for about 20 plus years. We were founded in 2002, actually, by a group of enthusiasts who were concerned about what would happen to their own collections, their own archives relating to the history of milling, which can also include water. We do cover water as well, but obviously for this talk, I'm focusing on wind and wind energy. We've got millions of records. So a record, like by record, I mean a photograph, a letter, and we keep getting collections as well. Mostly national, so mostly relating to the UK where we're based, but also some international material, particularly in the library. We do have books in different languages, and that's one of the reasons why we've sort of got to know the World Wind Energy Association, because we're trying to sort of raise awareness and raise our profile internationally as well. And what we do, so we've moved from being entirely volunteer-led to having a small team of staff, but we're still very dependent on our volunteers to do things like cataloguing and digitization. And what we're looking to do is protect, preserve, and promote the history of milling, wind and water power. So we're mainly talking about the traditional wind and water mills. That's the majority of what we've got in our collections, and pre-electricity in that regard. And what we're trying to do is really it's just raise awareness of all the efforts that have been put into wind energy and water across hundreds of years, raise awareness among the public, and show how history is relevant to today. So relating it to contemporary issues like climate change, for instance. That's the picture of us in front of the building where we work. We work in Watlington House in Reading, which is a really grand, lovely old building. And we're an accredited archive, I should say, as well. So the UK National Archives has an accreditation program, so we meet various criteria. So these are just some snapshots, if you like, of the sorts of records that we've got. We've got obviously lots of photographic materials from different time periods. We do have correspondence, really big sort of indentures, so like legal deeds, handwritten, beautifully illustrated. What else? Artworks, negatives. We do have some objects, not that's not our priority because we are an archive. So I'm just showing you here the range of materials that we've got relating to wind energy. So in recent years, we've been focusing also on collecting records that relate to developments from like the 1970s onwards. In particular, we've had a collection from someone called Dr. Peter Musgrove, UK-based. He co-founded the British Wind Energy Association in 1979, and he's given us his collection. And he was particularly active on the vertical axis wind turbine designs. And all of this is sort of supported by a strong library of books from relating to electricity generation from the sort of late 1800s onwards, really. We were introduced, so the Mills Archive Trust was introduced to the World Wind Energy Association a few years ago now, I think it was, by Kolya, who will be featuring, who's actually here now and he'll be talking a bit later as well. And we found out that both of our organisations were looking at this issue of advocating really for the importance of preserving archives relating to wind energy and trying to learn what's out there, and also approached the issue internationally, because it is all, the national stories are all interwoven with the international picture. And I'm pleased to say we actually met in person for the first time. That was in April, actually, so not that long ago. We managed to get a small grant, and I'll mention that a little bit later as well, and I know Kolya will as well. But yeah, met in person, met Arne, who's in this picture, who's also talking later as well. And Stefan told me that our picture even featured recently on the WindTech International website. So we went to the German Windpower Museum, which was fascinating. So like I said, I'm going to go slightly back in time first, before the 1880s, but not for too long. And what I'm trying to do is sort of show you, if you like, how what inventions, what discoveries, if you like, were being built on by the time of the 1880s. So wind has obviously been harnessed for hundreds of years, and the first type of windmill that we see is called a post mill. So it's this whole structure can be turned around a central post. They were made out of wood, and the focus was on grinding of grain to make flour to then make bread. There are some disagreements about their origins. So some people think that the technology was first invented in China. Quite a few people think some are in Persia. But what you see in terms of documentary evidence for them, I think it was the 12th century. There's a document, an English document mentioning a windmill. So that's sort of one of the earliest records. And then over time, they became very successful because obviously, if you live in an area where water isn't strong enough, you can have a windmill. You could build them quite cheaply. In the feudal system, you'd have the lord of the manor. He could build the mill cheaply, rent it out to a miller, and also require the local people to use his mill. And they had to also give him a portion of their grain. So all of these things kind of encouraged some of these wealthy landowners to start using windmills. And I would say it's one of my favorite pictures, but this one on the right, it's a reproduction of a manuscript. I'm not too sure which one off the top of my head. And it's suggesting that windmills were sometimes being used in warfare to launch angry bees in beehives over castle walls. So I guess that happened. I just think that's really, really cool. And then what you see, so then you have a period of several hundred years of evolution, really, of the design. So like I said, we started off with a traditional post mill, and you still see them in some places, don't you? Particularly where they've been preserved. But then over time, people were looking at how could they produce more, and how could they make the machines more efficient. So you see changes in the size of them, in terms of height, in terms of diameter, number of sails, what they were made out of. So moving from wood to brick and also then metal in terms of the mechanisms. So what we've got here are the different examples. So there are two post mills on the left, and then you've got the smock mill, which is the very traditional kind of, when you think of the Netherlands, that's the sort of smock mill shaped windmill. And then we've got what we call the tower mills. So then they're almost like lighthouses that just happen to have lots of sails on them. And like this picture, could be 4 sails, could be lots and lots more sails. If they were taller, you could also put multiple floors in, because what these sails were doing obviously was driving the millstones. So you could have multiple floors of millstones, so producing more flour to bake the bread. Something that I find quite interesting, because visually it's very similar, is looking at the development of the sails themselves. So I'm aware that obviously wind turbines, they're called blades. And I believe it's called feathering when you're sort of looking at the aerodynamic shape of them. Whereas in terms of traditional windmills, that effect is called weathering. So this is an example image here where you've got this, I think it's a sort of mid 20th century, and it just to show you that these sails weren't flat. They were actually angled to catch the wind better. So incredible engineering feats back then. And windmills were at their peak from the sort of 1700s to mid 1800s. Obviously used to produce food, but were used pretty much for any industry that needed motive power. They then start to decline. So you've then got the Industrial Revolution. You've got more bigger populations. People are moving to the towns. So, and also cheaper grain, including from abroad in certain places. So what you then see happening is these really big factories basically being established. The milling technology in terms of the food production, the flour production was also developing. So these really big factories could have multiple roller mills rather than millstones, which could produce white flour. And the small traditional windmills just couldn't compete. They were rural. They didn't benefit from being surrounded by the fields anymore. So a lot of them fell into disrepair. But thankfully, there were people back then who could still see the value of them beyond, preserving them for cultural reasons. That people were looking at them and thinking, well, could this technology be utilized instead to generate electricity? So people were starting to ask those questions. And obviously around I think it was 1870s, we're seeing more and more developments in electricity generation as well, and development of lamps, different types of lamp, and electricity was started off, in the big cities, but over time, lighting up public spaces. But over time, it was also becoming more affordable to be used in people's houses. I did a bit of digging. This was actually over the internet. This wasn't in our own archive, but this also really makes the point of the value of archives, I would say. There are some really interesting digitized journals, and I enjoyed going through them, trying to see if I could find really early conversations about electricity generation potential of wind. So I found one in 1872 where the other thing that these show as well was that people were concerned about the use of the fossil fuels and how finite they were and their costs potentially going up, so particularly coal. So 1872 article, this person's talking about the use and abuse of coal, and it's getting very expensive. At some point we'll run out of it. Although he didn't think that wind would be a goer. He felt, compared with the steam engine, it wouldn't be economical. Then we see 1881, someone called Sir William Thomson, again talking about concerns about coal supply, but he did feel that wind could be utilized to generate electricity. What he said, though, what he added to this was that he felt that the technology wasn't at a point yet where it was economical enough to do it. So he felt more work still needed to be done. So interestingly, this is 2 years before what we now know to be the earliest example of a wind turbine being built to generate electricity, which I'll come back to. Someone else called Mr. Lane Fox Pitt was asked in another article about how much it might cost to light a house with electricity, and he was saying, well, if you have a windmill, it would actually be quite cheap to do. Lane Fox Pitt actually got a patent as well for a light bulb, which was acquired by someone called Charles Brush, who was an American pioneer, who I'll also come back to. So I thought that was quite a nice sort of connection as well. And we will all have heard of Siemens and William Siemens. And I should have probably changed the name of my presentation to Pioneers in the Domain of Nature, because I just think that sounds really, really powerful, so to speak. He had quite an extensive article in 1882 where he was talking about the benefits and the value of electricity, because it's easy to take these things for granted now, isn't it? That of course you would have electricity, why wouldn't you? But again, what we're now seeing is a more positive view on the value of the potential use of wind, for instance, to generate electricity. He also talked quite a bit about the polluting effects of coal burning, for instance. Okay, so thank you for listening to the really early stuff. And as I say, that's just to give you a bit of context. And because I think what you'll find is that people were building on the inventions and the work of people who'd come before them as well. So now I'm going to look at some of the individuals who were involved and look at some of their stories as well. So Joseph Friedlander is a really interesting case in his own right, because this again is direct evidence for the value of having archives. Someone actually uncovered this I presume it's a large technical drawing. It's at the main university library at Zurich University, and they found this illustration of basically a wind turbine designed by Joseph Friedlander, who was an Austrian engineer, and it was installed at the Vienna International Electrical Exhibition. It had about I think it was 6.6 meter diameter windmill, and it was in the style of something called a Halliday windmill, and I'll show you a picture of one of those in a minute. And it powered a dynamo, charged a series of batteries, and then it was displayed powering an assortment of things. But there wasn't much evidence that he then continued in this area. And I have to pay full credit to Paul Gipe, because I know this was also discussed at a previous World Wind Energy Association webinar, actually, that Josef Friedlander and his work. But I know we've got Paul Gipe in the webinar watching as well. So thank you very much to him for his blogs and his articles. Very helpful for putting this together. So this was one of there were actually a couple of different types of Halliday windmill design. So I'm not 100% certain which design it was. But I was talking to one of my colleagues yesterday, Mildred, who has her own collection. She was a miller herself for 30 years at a water miller. And she dug out these really striking images for me. So these show some of the designs of a Halliday windmill, which originally wasn't built to generate electricity. It would be used for things like water pumping in remote areas. Daniel Halliday, pictured here, American engineer, and his first patent for this was in 1854, and it was meant to be what's called like a self-governing windmill. So what he was trying to do was minimize the human effort needed to adjust it, so either to turn it into the wind or to change the sails, so to speak, so if the winds were very strong, they were even then they were concerned about the windmill going into overdrive and damaging itself. So because previously quite often you were relying on human intervention with the windmill, so you'd have the miller going up and reefing or furling the sails, it was called. So if they were wooden sails, it was opening them up to let the wind through, or if they were canvas covered, it was sort of furling them, wrapping them up. So he made developments in this area, and I thought this image was really interesting as well, the bottom left. And I have to admit, I don't have a naturally engineering mind, which probably most or many of you do have, but it did this thing where it kind of folded in on itself when it was very windy, for instance, so to sort of reduce that chance of it going into full force and breaking itself. So prior to 2022, everyone thought that the first person to build a wind turbine to generate electricity was someone called James Blythe, a Scottish professor. He's still sort of credited until someone discovers otherwise, which could still happen, which is really exciting, with generating electricity to light up a house, which was his holiday home actually in Scotland. And so he built this early type of wind turbine. This particular picture, I'll show you another one on the next slide, but this image, is just one example. So because he was prototyping them, and he did a few different ones, I think, over time. The one that he first built in the garden of his holiday home could power 10 light bulbs in his house in a moderate breeze. He got the patent in 1891, and then he worked on his design to improve it in 1895 as well. And he actually built one for Montrose Asylum in Scotland, which operated until 1914. But there was a big issue with his design, so that there wasn't a braking mechanism. So if the wind was too strong, it could be damaged. And even when he tried to work on that, he still had the same problem. This is another. So presumably this is the first one that he did. And we found these particular. You can find these images online, but I also thought I'd include here an image of a book that we've got in our library here called Natural Sources of Power. So that's a 1908 book, which has a little bit of information about James Blythe and has these images reproduced in it as well. Now, thank you again, Paul Gipe, in partnership with Eric Mullerstrom, because I could find very little about this person. Also 1887, but just a little bit later than James Blythe, Charles de Goyon, who was a Frenchman. And with a group of people, they designed a wind turbine, and what they were doing were charging batteries for commercial sale. And it was also he also designed one at some point to then power a lighthouse as well, and that was funded by the government there. So if you're interested in finding out more, among many other things, Paul and Eric also have published this article. It's open access, so you can, and it's just part one, so you can also read on more if you would like to. And he was using a design similar to those being used in North America and in Europe, again, looking at this issue around trying to reduce the need for people to be involved in, reefing them, as we would say, if they were traditional mills. So reducing that likeliness of them damaging themselves in strong winds, so automatically self-regulating. Someone else who is particularly famous, I think, is Charles Brush. So the following year, this is in America, so he's an American inventor and engineer. He designed a wind turbine using this sort of multi-blade design, and I found this front cover online, which is presumably from a digitized journal. So again, we need to get journals digitized and available online. And you can see one of the illustrations here. So massive, so that the multi-blade design, but they tended to be much smaller, the ones that you'd see like in these rural homestead type views. But yeah, very chunky. And he built it in the garden of his mansion. So he built a mansion apparently to in Cleveland to demonstrate his various inventions, and this was there, and he used it for quite some time until 1908, and it could apparently power 350 incandescent lamps, which sounds like quite a lot. And again, unlike Blythe, it was self-regulating, I believe, so it could protect itself. I suspect quite a few of you have heard of this gentleman as well, Paul Oelker. So we're all aware of the role that Denmark has played, and the important role that Denmark has played in terms of wind energy. And it kind of goes back to this gentleman. He had a lot of successes in his life, very talented scientist. Even before he moved into wind power. But he moved from Copenhagen to somewhere called Askov, and he worked at the high school there. He taught at the high school, and then he began experimenting with wind energy. And he managed to get a grant from their government. He was looking at things like, how do you regulate the turning speed so you don't get these big spikes? So he developed a new piece of technology called a catrostat. I've probably pronounced that terribly. The other thing he did, and again, I got this from Paul Gope's article, wind tunnel experiments, which I think sound fascinating. So 1897, he was doing that to see, to make sure how could you make it as aerodynamic as possible. And the other thing I liked in Paul's article was he talked about millwrights. So millwrights are the people who had the knowledge to build and repair the traditional windmills. So again, for me, this is just showing it's building or reinforcing, if you like, the traditional knowledge that was already there. That in this case, 4 blades were actually better than 6. He was involved in lots of different things, and he wanted to see living standards raised through education. And one of the ways that he did that was through publishing his research, and actively adding to that sort of lively science community as well. The images here, we received permission from the Oelker Museum in Denmark to have them on our website, so we're very grateful for that. So if you are interested in finding out more, and I'd love to go and visit them sometime, I'll have to work out how to do that. But yeah, an entire museum dedicated to Paul Oelker and his work in a particular part of Denmark. This gentleman, I'm slightly cheating in that he wasn't a pioneer in the same way as the others. So he wasn't someone that, as far as I'm aware, designed a wind turbine. But what he did do was he used a windmill to generate electricity on a ship. He, very interesting guy, did lots of different things, very accomplished, Nobel Peace Prize, designed something called the Nansen passport for stateless people, sort of particularly after the First World War, I believe, people who'd been displaced, so they could still travel around. And an explorer. So one of the expeditions he went on was to the Arctic on a ship, 1893 to 1896. And yes, they built this wind turbine, which generated enough light for the ship and for the crew. You can find he wrote a couple of books, which, from what I can tell, are he obviously wrote extensive detailed diaries, and these books illustrate and discuss, what his observations. And he wrote a lot about the wind turbine, actually. And Mildred, again, my colleague Mildred, has beautiful old books with, and you can see this little gold windmill there. But you can actually find digitized versions of these books online. So again, value of digitization and archives. I wanted to just mention a couple of things actually in his book because they're just so curious. The black and white images. So this one is the ship is a photograph, and then this one is an illustration, and it shows a little polar bear here. So apparently, they found a couple of his crewmen were on night watch or just finishing up night watch and switching over, and there was ice surrounding the ship, and they could see this white blob. And they thought, was that a polar bear? Starts moving, is indeed a polar bear moving towards them, and they think it was actually attracted by the movement of the windmill. Would you believe it? But sadly, they, I guess, understandably, had to shoot the polar bear, and they had roast bear for dinner that day, so that must have been very nice. But he talks a lot about the psychological benefits of having electric light on this ship. He said things like, let's see, I've got a quote here. So southwesterly wind, the windmill has been ready for several days, works splendidly. We have beautiful electric light today. Electric lamps are a grand institution. What a strong influence light has on one's spirits. There was a noticeable brightening up at the dinner table today. The light acted on our spirits like a draught of good wine. Yeah, so I just really like that. Oops, I've skipped through my slides there. Okay, this was the exception that I mentioned. So I'm meant to be stopping before the First World War, but I really wanted to mention someone called Edward Lancaster Byrne because he's very close to our hearts at the Mills Archive. We have a collection of relating to him, so his correspondence, his large technical drawings, photographs as well. English engineer. He was interested in the sort of traditional windmills in general. We've got evidence he was good friends and a correspondent with windmillers, traditional windmillers, and other experts in that area. But clearly he was, looking at how they could also be used to generate electricity, and he ended up actually registering 3 different patents. That's obviously a picture of him there. And the way he approached them was he built them out of wood, certainly to begin with, and it was like a smock mill. It's like I was saying earlier about the different types of mill, and you think about the Dutch mill, and it would be assembled on the ground, these sort of 6 sides put together. He did a lot of experimentation at home. This is one of the photographs that we've got, which actually shows a little bit of damage. So this discoloration at the top is damage to the image. So we've still got the physical image, but we've also digitized it. So at least if, as and when the photo perhaps gradually eventually decays, we've still got digital image. And he sounds like quite a character. And his daughter, in later life, reflected on watching her dad sort of doing these crazy inventions in the garden at home, and she talked about that again, the magic of being able to just turn on a switch and a light, and it wasn't a bright one. The lampshade was made out of a flattened cocoa tin, but it was a real light, and so they didn't have smelly oil lamps. And she always saw him tinkering, and apparently at the beginning he made things out of anything, like out of like a whisk, like a kitchen whisk, and all sorts of tinkering around. But over time, what he was doing was he was honing his ideas. So on the left, the image on the left is a prototype that he was building. He worked with particular builder who they didn't work with they hadn't worked with this sort of thing before, so people aren't entirely sure why he chose them, but they had experience constructing other things. And then you see the image on the right, and in fact this is actually not too far from where the Mills Archive Trust is based. This one of these examples of his early wind turbine, which I just think is brilliant. Another example on the left, I think that is probably, so he lived in Blackheath, so I think this may well have been one also in his on his grounds, if you like, as well. And something really cool that happened, actually, I think that was as a result of a World Wind Energy webinar, was someone contacted me afterwards. I don't know if they're in this call actually, renewable energy professor, and he knew about Lancaster Burn, and he knew that there was at least one example of a Lancaster Burn wind turbine in Australia. So, and I've had a look, and since then they've actually done a lot more digitization. So you can see now. So this is the University of Melbourne Archives. It's a particular collection, and it was a wealthy family, the Grimwade family, and they had this Lancaster Burn wind turbine in their garden for quite a period. So this photo is from 1931, but there's photos going back to 1924. So I'm now dying to find out more. I think they do have some diaries that I believe talk a bit more about how it actually got there, and yeah, how that connection was made. So that was just like a whistle stop tour of the key pioneers. I'm just keeping an eye on the time. I think I'm doing okay actually. So I'm pretty much done now. Lots more to come from my colleagues. But if you don't mind, I also wanted to just give a short plug to a project that we're running at the moment called Mills to Megawatts, which some of you again might have heard of. So we did get a small grant from the European Commission and the Council of Europe, ourselves and the World Wind Energy Association. And what we've been doing with it is start to understand what other archives exist in Europe, and whether we can create a network in the fullness of time to sort of share knowledge, share ideas. And another part of it has been developing a map where we're sort of plotting historical points up to present day that relate to wind energy to try and show, that development in different countries over time, initially focusing on the UK, Germany, and Denmark, just because of who's been involved in this project. But there's a lot more opportunity to grow this. So if any of you do have a look at this and have ideas, or just generally have ideas or suggestions of what we should include on the map, do get in touch. And subject to funding, what we hope to do is expand on this and also look globally, beyond Europe as well. So I think that was me. I hope that was all right, and that I wasn't muted the entire time. You've all just been very polite. Thank you.
Liz, that was a fantastic presentation. I think
Good.
really summarizing the first decades of wind power development. We really have also great guests here. I mean, some of them are very knowledgeable as well. So let me just say also at this moment, I thank you very much for also the work that you're doing, because you're really doing great work. We are now in contact with organizations that are also having some archives or so, but it's probably, as far as I'm aware, of the best place in the world at this point of time, which is collecting so many items, 3 millions you've mentioned. So as we do have people here who really know a lot as well, I think let's also invite people, if anyone would like to ask a question or know something that maybe is not yet in the records, and I think this is what this all is about, then please feel free now to raise your hand. If that's not the case, I think people are just find it amazing. Then thank you again, Liz. You will stay here, of course, and we then move to the next period. And now let's move to the first kind of industrial activities period. And it's my pleasure to welcome here Jan Oelker. I think many of you know him as a journalist, photographer in particular. Jan, I think the most famous publication that you've made is this book in German. It's called Windgesichter, probably Wind Faces, something like that, which in itself is now also, I think, an historic piece. Jan, great pleasure and honor to have you with us here as well. And if I may hand over to you. You should just now unmute yourself, and then we can hear you.
So, okay, you can hear me now?
Yes. I think if you just click on that small button at the...
Yes, I look where I hear audio.
No, that's working. Just you don't have full screen at the moment.
Ah,
Probably you go to that right at the bottom, unten rechts. Das vielleicht?
So, is better?
Na, klick mal da. Ja, perfekt.
Okay. Yeah, thank you for inviting me for doing this lecture about the history of wind power. I will concentrate of the period from after First World War till 1970. As you mentioned, I'm a photographer in the wind energy. Since 1992, I'm observing the development of wind turbines especially in Germany, but also in Europe and was in US and China. And in 2005, I published the book Windgesichter, Wind Faces, about the history of the German wind industry. But this is the topic of this period is the topic of Arne's lecture after me. I will tell a very good source of history for all the participants here of this webinar. Is a dissertation of Matthias Heimann, the history of using wind energy from 1890 till 1990. It was sold out at all in 15 years ago, but Professor Martin Schieber, who works for Offshore Stiftung, Offshore Foundation in Germany, he made a reprint, just that you know it's still available. You can look at Amazon, you find it really. It's a really good source, his scientific work. I'm from Dresden, and who knows German situation, or special the Saxonian situation in modern wind energy, he can't believe that Dresden before the First World War was a hotspot of German wind industry. We have two big companies here, the Sächsische Stahl-Windmotorenfabrik, and there's still one turbine existing in Germany in Weltersburg in Westerwald. Is a pumping system. And the second was the Vereinigte Windturbinenwerke Dresden. They produced a similar turbine with the name Hercules, this named Athlete. And the third huge German wind power manufacturer was a company Voss in Marne. They produce the Adler wind turbine, and this is in Süderwisch near Marne. The Voss company is situated in Heide, and it was overtaken by Friedrich Köster. Also is Friedrich Köster Maschinenfabrik still exists, but not make directly wind turbines today. But they had a long tradition, and this is one of the here two existing turbines. They were for electricity, for producing electricity. Is situated on a farm in Süderwisch near Marne, in Schleswig-Holstein. This, of course, was not for a grid connected, it was feeding batteries for an insular system. In 2019 in Denmark was the development to making grid connected turbines, and this was the patent of Johannes Jensen and Paul Winding. But they had in their patent, had a synchronous generator and connected with he drives electricity to an asynchronous a mechanical power to an asynchronous generator. On top was a synchronous generator with the DC. It goes down, has a motor with DC, and then coupled with an asynchronous generator to the grid. It works with grid connection, but the agricultural windmill, but not so efficient at this time. The most systems of this time were the chargers for batteries, like in US, there were built thousands of this wind chargers from the company Jacobs. One inventor in Germany was Kurt Bielau. He was an officer, major after World War I. He thought about a new field to do something, and his idea was to have decentralized energy supply. He was not a huge fan of the growing grids because he, as an officer, see it in the wartime. And on the other hand, he sees that it's dangerous. And now in Ukraine, you see that the centralized grids are very fragile. And that's why he developed turbines for power supply in remote areas, and also for old windmills. He said you can look old windmills. You can always also power by wind turbines, as it was in the past. Here, this is thank you for Uwe Carstensen. He made two books about Kurt Bielau and has an archive of Kurt Bielau that can be interesting for you, for this project, Mills to Megawatt. He has it still private, but he will give it in the archive of the Mühlenverein Mills Society of Schleswig-Holstein and Hamburg. And he has also from the relatives of Bielau a lot of photographs. And here you can see Kurt Bielau experimenting in Driesen. This is in Pomerania, now in Poland, Treścienko. He has here an experiment with 4 blades or 3 blades. All the questions, they are not solved. Then he built in Eastern Prussia a turbine with really huge aerodynamical blades in 1920 in Kukene. Kukene doesn't exist, and this windmill also doesn't exist anymore because its operation time was just 5 minutes. The blades was too huge, too big, and they break down at the first run. He made many Ventimotors. He told this Ventimotor, but this has nothing to do with a Ventimotor company I will later talking about. He told this Ventimotor and built several in Eastern Prussia. I think on the same tower. He has huge concrete towers for this turbine. And yeah, here 60 horsepower is written, but 44 kilowatt is this. And in 1924, he let build a turbine by a Berlin company, Aerodynamo, and exported it to Oxford. And near Oxford in Great Britain was a test site. And there's written in this book that they had 5 English turbines, 1 Danish and 1 German there tested. And here he has, of course, no concrete tower. This is also a repeller turbine or a Ventimotor type. He experimented then with influenced by the science of Betz and the aerodynamical science. He made repeller turbines, and here he supplied it to a windmill in Deutschbrod, Havlíčky Brod. It's in Czechia now, Czech Republic, in Eastern Bohemia. But this was later built. But Bilau's main advantage, you can still look till nowadays, is the Ventikanten wings for old windmills. He built blades. They look like, if you look at an airplane, they divide when an airplane is landing and will go down with will manage stall, then they divide the wings, and this he made with his wings, and there are still existing in Germany and in Netherlands 10 of such windmills with Bilau Ventikanten. The 1920s was influenced by the aircraft development, was a lot of scientific works, and the main scientific work for the important for nowadays is this of Albert Betz and at the Aerodynamic Experimental Institute in Göttingen, Aerodynamische Versuchsanstalt. He wrote in an article, he determines the law of Betz with a maximum, theoretical maximum of the use of wind power. That is 59% of the stream, of the energy of the airstream just is usable theoretically. This was really groundbreaking because the coefficients always were estimated much higher, but this is an aerodynamical law. A lot of inventors were there. In 1922, the Anton Flettner, a German engineer, invented the Flettner rotor using the Magnus effect. It was also at the AFA, also the Aerodynamische Versuchsanstalt in Göttingen. They had observations with the Magnus effect, and Flettner saw this for sailing boats. And I photographed here the E-ship from Enercon. Only few times it was used, and the best hidden secret on the ship was how efficient it works, how many fuel it saves. The Sigor Savonius, a Finnish architect, also influenced by this researches, invented the Savonius rotor to they using the Magnus effect in another way, and there are two effects overlaid. This photo I made in the very eastern village of in Chukotka in Far East Russia on the Bering Strait. Carpenter drives his chainsaw with this windmill. And this carpenter told me about a turbine that stands in ULAN, and I will tell later when I talk about the Soviet Union. Last not least, Georges Jean-Marie Darrieux invented in 1925 the Darrieux rotor. It was a time of invention. Many things were developed. This is in Plan du Pal in France, in southern France, and is still working, but it's not from this time, of course. I was in Russia, and they told me that there were a lot of old wind turbines, and thank you for Jos Berskens. He gave me a couple of years ago some photographs, some scans of an album of photos from the Russian wind industry. And this was situated mainly in the Centralny Aerodynamiczny Institute. Also this is Aero and Hydrodynamic Institute in Moscow. It was founded in 1918 and has a department of wind energy in 1920, and they developed wind turbines with self-aligning blades. In Moscow, they tested it in small systems, and then it spread over the country. This was on was ist das? On a agriculture exhibition in Moscow. They show one turbine. It was mainly aimed for powering remote villages or to pump water. This is a pumping system near Odessa in southern Ukraine, also with rotor diameter of 8 meters. This is an oil pump in Baku oil fields. They try to do it with wind turbine. This is a pumping system. Has a power output already from 37 kilowatt. Then was a huge program. The Russians, after developed, made a department for the Northern Sea route through the Arctic. It was possible by the first cross was in the end of the 19th century, and they constructed harbors on the coast of the northern coast on the Arctic Sea, and this very remote areas, and they made power supply for this stations, also weather stations they built, and constructed special turbines, the D12 in Dixon Peninsula, the Timea is in the Siberia north. And the carpenter in ULA told me that such a turbine also used to stand in ULA, but it was not anymore. The most famous turbine in Russia was a WWEA D30 in Baklava Peninsula. Also WWEA, these are the book of Sjesajuzni Institut Mechanizacja I Elektrifikacja Sjelskog Hozajstva, also Institute for mechanization and electrification of the agriculture. It was built in 1931 on Crimea Peninsula, but unfortunately there was a war too. The Germans destroyed it in the siege of Sevastopol in 1942. I found this picture in the internet. I never found it again, but I had it, and this was cool. And there were some of the Russian, they were intended to build greater turbines. Here they have a design study, they named it Icarus, and they have a huge 165-meter high reinforced concrete tower for this turbine plant. The constructor, the architect of this tower, he made later the TV tower in Moscow, is 500 meters high. Also he had these ideas very early already in the beginning. Yeah, this was a time they all were intended to build, all countries were intended to build great turbines, and now the and importance for industry it just become if the turbines are bigger than 1 megawatt, The most fantastic, in the real world, fantastic plans had Honnef, this is a Reichswindkraftturm, also Imperial Wind Power Tower. He built this in 500-meter high tower, and yeah, with 73 megawatt power, these three turbines. It's very high estimated because 160 meters nowadays makes 5 megawatt one turbine, and he has three. uh, it was fantastic, but fantasy. Also, a huge plan was the Emma project of Emma and Kleinhans in 1942. But anyway, it was uh, no chance to build this. It was already the time of war, and whether in Russia nor in Germany any big turbine was built because all the material goes into the war industries. And so some suitable wind mills are constructed in Denmark with a 70 kilowatt turbine in 1942, the FLS Aeromotor. And of course, the world's first megawatt size wind turbine at Grand Pass Snow from Smith Putnam in USA. The war interrupted everything, and there was also a need for smaller turbines, and there was especially in Germany some inventors like Wilhelm Teubert. He tried to make small turbines together with Gute Hoffnungshütte, and then you have the company Ventimotor. It was by Walter Schreiber owned. Walter Schreiber was a member of the SS, an intimus of Hitler, and he suggested to make wind turbines for the eastern areas they occupied in the war to feed their power, to bring power to the eastern occupied areas in Ukraine and Russia, Belarus, and everywhere in Europe where they are. Where he has a testing site in Weimar. And at this testing site, Ulrich Hütter can he can build one of his turbines and make studies, and he made his dissertation a contribution to the creation of design principles for wind power plants. He wrote in Weimar, but shortly after published his dissertation, he was sent to Stuttgart, and he must also develop systems for war industry. The wind power comes to a stop, but the war in the end also, and so in Germany it was prohibited to the engineers, they are in the aircraft industries, were prohibited to develop aircrafts in the post-war period. So at both sides of Germany, also in the Soviet zone, the Allies allowed them only to do civil works, the aircraft engineers. And in Rostock, there were three airplane factories, and one of these constructed windmills for pumping systems and small chargers. This is a company, EKM Windkraftwerke. EKM means Association of State-Owned Energy and Power Engineering Companies. And they built a small wind pump, and with a diameter of four-bladed, with a diameter of 4.6 meter, and charger with a 200 watt for remote areas. In West Germany, the story of Hütter in Stuttgart is well known. He went to the company Allgeier in Uing and constructed the WE10. Here is a small test site. From the beginning, they tested their turbines on tripod or on a steel, singular, on a guide tubular steel tower. The Hütter turbine has a diameter of 10 meters, 6 kilowatt, at a hub height of almost 10 meters. And they made a market estimation and saw it especially in remote areas in Germany, in not grid-connected farms. And here, this is on Feldberg in Schwarzwald, a radio relay station feeding power for a radio relay station. But the most aim of Allgeier was the export. So they had a couple of wind turbines in the more than 200 are produced, and they send it to Southern Africa, here in Namibia, nowadays Namibia, and to Argentina, Abyssinian, this is today in the Sudan. This was a real export business, but the maintenance always was a problem. And this is the time. And if you send a mechanic to Africa, it could be more expensive than the turbine in the end was. But they have also higher towers, especially in Germany was this need, and this is in a Landesgartenschau in Hamburg, and garden exhibition or park exhibition, I say they show an 80-meter tower with guide steel tube. And Allgeier also created the first wind farm in Germany. 8 turbines stand in the Nendorfer Hamrich. This is a wet area. They feed a pumping station on the River Ems. It is now this place where this wind farm once was. This place is now the parking place of the Meyerwerft in Papenburg. The Allgeier WE10 also was an experimental wind turbine for a higher project, the W30 or 33. The Hütter let construct a 2-bladed version. And first, he have here rotor blades made by fiberglass. This was Hütter's greatest advantage, that he brought rotor blades made by fiberglass. This is a test site in Schwäbische Alb, Stettin. And the engineer on the test site and the keeper of the test site for many decades was Sepp Armbrust. He gave all this material I show here from the Allgeier and from the Allgeier WE10 and the W34. He gave all this material, a lot of photographs to the Stiftung Deutsches Technikmuseum in Berlin, and it's a huge photographical archive also. Here, these are experiments on the DVLR. This is German Aircraft and Aerospace Institute in Stuttgart. They made first tests with fiberglass rowings, and you see Eugen Hähnle in the white shirt and Sepp Armbrust. These are the first rotor blades. One half of this rotor blade here in the foreground is seen how he made the connection to the grid. It's a typical Hütter design. In summer 1957, at Allgeier factory in Ewing was mounted the next greater turbine, the W34. The erection was in the summertime, late summer, at the Schwäbische All in Schnittling, and you see here it is like it goes up. It was pulled up till this frame, and then the frame moved backward, and the turbine and places the turbine above the tower exactly. The W34 in Schnittling was the almost 100 kilowatt power output with 34 meters diameter, and there was the first really grid connected turbine, or they made grid connection here in December of 57. In Denmark, parallel, in 56, 1 year earlier, Johannes Juel built his wind turbine, and it was in a much easier, not so sophisticated way. It was practical. The Danish design, and Hütter and Juel, they were really in connection. Here's, in the end, I will bring a picture that is at Juel's first turbine, 15 kilowatt turbine in Eggesberg. Here you can see Johannes Juel, second left, and Hütter right, with two Indian engineers. They made a journey to Denmark, and these turbines from Juel and Hütter are at least basic of the common turbines, and Juel makes a practical stall turbines, and for the greater, if the turbines became larger, then more and more the input of Hütter became important. But about this, Arne will tell in the next speech, and I say thank you for your for listening to my lecture. Thank you.
Thank you very much, Jan. That was a fantastic presentation as well. Really a lot also for me new. I mean, this last picture is an amazing one. People even coming at that time to India from Europe, also kind of referring to the international dimension that all this has already at that time at the early beginning.
There was also meetings with the British and French. They have also megawatt turbines in this test turbines, but yeah, the time is limited.
Yeah, that is, I mean, for sure. We spoke in advance, and we noticed that actually half an hour, which each of our speakers has, is not a lot of time, and we could fill certainly hours and days with this. I'm just looking around whether anyone has anything to add or to comment on, or has a question. If that's the case, then please raise your hand now. I don't see that at the moment. So let's continue with our next speaker. Time is flying. It's very exciting. I'm really very happy to have this webinar being brought up. I saw, by the way, that one Miguel Cabrera probably had already to leave. We will, of course, put the presentations online on our YouTube channel. So it will stay there as part of the records of wind power history. Yeah, again, Jan, great thank you with this. Let's go to the last so far period that we found as important. And this is the time directly after, Jan, what you have presented now, leading into where we are today. And it's my pleasure to welcome Arne Jaeger. Arne, now you have made it. I'm very happy about that.
Yeah, thank you. Can you hear
Arne,
me?
yes, and you are, I
Thank you.
mean, you look very young, but you have almost 30 years of, as you always say.
1993, yes. I started in 1993. By the way, hello everybody, and thanks for having me here.
Yes, and you really already as a small boy, you became enthusiastic about wind power. You're very
Yes,
knowledgeable. Also related with the German Windpower Museum, where we had our
yeah,
meeting that
yeah,
Elizabeth already has mentioned. Arne,
yeah,
I just hand over to you
yeah,
for the so far more or less the last chapter of modern
yeah.
wind history.
Okay.
So
Yeah,
please
once
try to
again,
share.
yeah, okay. Okay, let me see if we can get this managed here. Okay,
So far, it looks
can
good.
yeah.
Just wait.
Okay,
Yeah, and
can
now you.
everybody see? Yeah, okay. So I was asked by Stefan to hold a short lecture about the more modern part of windpower history, 70s, 80s, 90s until 2000. So we are now looking shortly at the three more or less most important decades, which are considered, or which I at least consider as superstar decades, because they, in the end, led the way to modern wind energy. First of all, I would like to give you a short general notice. Um, since 1975, as we know, wind power technology has gone through an international and very fast-paced development. And we are looking at three very big decades. It's like standing in front of Mount Everest. So the time frame is way too short to include all the details. To avoid massive overload, I decided just to look at the most active and biggest countries of each decade, just as a general brief introduction to get an impression of what happened in these decades. So let's start with the 70s. In the 70s, we had two major countries, the United States and Denmark, to play a very significant role. The 70s have often been described as a decade of grassroots. At this time, it was more or less unknown which technical concept would prove best for wind turbine application. So in the end, more or less anything was built and tested, and there was a principle of trial and error. 1973 the crisis had caused a global first rethinking, led to international federal and private initiatives, not just in the US and Denmark, but Germany, the UK, Netherlands, some others as well. The point is that the US and Denmark, in the end, did most compared to other countries just like Germany or the UK or Sweden. So let's look at the US. The United States had a federal wind energy program that was commenced in 1973. And the overall aim of this big federal program simply was to accelerate research, development, and the commercialization of reliable wind turbines in the United States. It was a way to create competitive American wind industry. There were three areas for which funding was available. There were projects for small wind turbines of a few kilowatt. There were fundings available for intermediate projects. At the time, the term intermediate was used for wind turbines around 200 kilowatt. We don't use that term intermediate anymore. In the 70s, they did. And large turbines of 2 megawatt plus for more commercial application. The general technical approach the Americans had was simply to apply know-how from aerospace and helicopter technology and transfer it on wind turbines. That is what they did. And to finalize this, in the end, this approach unfortunately failed more or less. But it was what they did. Anyway, in the late 70s, the Americans had a diverse industry mainly for smaller wind turbines up to 50 kilowatt. And we will soon have a closer look at this market. There were larger wind turbines, intermediate size built by famous company Westinghouse, and of the multi-megawatt size built by even more famous company, aerospace company Boeing, between 78 and 87. It was the so-called Mod family. There was another very important player on the US side, so-called Rocky Flats Test Station, Colorado. That was federal testing of smaller wind turbines, mainly from the US, but also from abroad. They had small Danish machines as well, some machines from France, from Aerowatt, and even from Switzerland called Electro. So here's a copy of interim report from October 1975 from the Federal Wind Energy Program. I have included this just to give you an example of what Americans did in the mid-70s already, at a very early point in wind energy development. Here is a typical example for development of a small 2 kilowatt turbine. We have on the upper left side the company Enertech, which evolved as a very successful company in the 80s. Enertech took part in the big California wind rush. Enertech was founded in the mid-70s, and they first built machines between 10 or 15 kilowatt. So we have funding of 150,000, and the period was 1978, 78 till May 1980. So at that time already, Americans invested a lot in the development and testing of wind turbines. So here we see DOE stands for Department of Energy. Department of Energy was the main institution to carry out and organize and coordinate the entire federal wind program. And Rocky Flats plant was the test station where this 2 kilowatt Enertech was later tested. This is an example out of a very, very long list of contracts. Here's the contract number, upper right side, of contracts between the government, more or less, the US DOE, and various companies from the US and abroad, simply to develop wind turbines of various concepts and sizes. Here's another example of an aerospace company on the upper left side. The Grumman Corporation was involved in the development of an 8 kilowatt wind turbine generator. And once again, look at the period, January 77 to September 79. At that time, for example, in Germany, people were talking about Grovian, if that turbine should be built or not. At the same time, Americans were already making concrete developments. $310,000 for an 8 kilowatt wind turbine generator. And here is exactly what that Rocky Flats plant looked like around 1980. This is an excerpt from beautiful publication by NASA called Capturing the Energy from the Wind. And I will read out this text here in the upper part. Row 1 at Rocky Flats has a group of prototypes. From right foreground to left are Enertech 2 kilowatt, this machine here. ASI Pinson 1 kilowatt, the cycle turbine, this machine here. Northwind 2 kilowatt in its shutdown mode is here. And in background below the vertical blade of the cycle turbine, a wind turbine from our friend Burgee. 3-bladed Burgee Windpower WWE1000 is this machine here, the far distance, rated at 1 kilowatt. The lower left is the 3-bladed Catco, rated at 3 kilowatt. It is this machine. So Rocky Flats played a very important, major part, played a major role in the development of especially American small-scale wind turbines. There was a lot of discussion at the time if it is right to put so much money in these developments and if it's right to apply aerospace and helicopter technology. Well, today we know it was not right, but at least a few companies like Burgee or the later US Windpower evolved from this period and had quite a successful time, and Burgee until today. I also have to add that most of these companies unfortunately failed in the 70s and 80s for various reasons. But one have to stress the fact that at least the Americans did a lot of research at that time. Here's another shot from 1980. This is the American Grumman machine I had mentioned previously at the Federal Rocky Flats Test Center. Here in the background, we see a 10 kilowatt machine made by Windworks. Windworks was another American pioneer of the 70s, early 80s. In the far distance on the right, we see a three-leg tower for Pinson. Pinson wind charger was a very small turbine of a few kilowatts for remote application. And we can see a vertical axis Dario machine made by DAF. This is Dominion aluminium fabrication. DAF played a major role in the 70s, 80s, developing vertical axis wind turbines. At that time, there were several technical terms like HAWT and VAWT. HAWT, H-A-W-T, stood for horizontal axis wind turbine, and VAWT stood for vertical axis wind turbine. Then we had a term called WECS, W-E-C-S, standing for wind energy conversion system. And we had a term SWECS, standing for small wind energy conversion system. As far as I know, these terms are no longer used today. Back in the 70s and early 80s, people did. Let's have a closer look at the bigger wind turbines of the so-called intermediate and large size. Department of Energy, NASA, HAWT, there we have it, Horizontal Axis Wind Turbine Research Program. So here we have a clear proof that starting in 1975, American federal research was already aiming at large-scale technology as well. So we have companies like Westinghouse, General Electric, and Boeing building two-bladed wind turbines, very impressive machines, by the way, between 100 kilowatt and 2.5 megawatt at that early point in time. Here, this is a very good proof back in the 70s. So here we have an overview of the so-called Mod OA turbines. That was the so-called intermediate size turbines between around 200 kilowatt, built by Westinghouse between 78 and 80. There were 4 machines of that type. Technically, and economically, they failed in the end, but at least a lot of practical and technical experience was gained. Again, there was a lot of discussion if this is the right approach or not. But I have to say, in the end, it was at least right to build it, because wind turbine technology is not something you can just read in a book. You have to do it. You have to practice it to find out which concept is right and which is wrong. The company Westinghouse had a commercialized version of these downwind two-bladers in the mid-80s. Westinghouse built a 15-turbine wind farm on the island of Hawaii in 85. They had upscaled this turbine from 200 kilowatt to 600 kilowatt. That wind farm operated, I think, somewhere until 90s. I don't think they're still operative, but at least Westinghouse tried to commercialize this machine. 600 kilowatt in the mid-80s was a bit too large, but I think it was worth mentioning. Let's now look at Denmark. Totally different situation. We had a number of small private initiatives across the entire country, which I call grassroots development. In fact, the company Riesager Mölln, was the first commercial manufacturer, starting right in 1973. Riesager built 3 bladers between 22 kilowatt and 55 kilowatt. He built and sold these machines before and during the twin turbine was built. So it's important to stress that twin was not the very first wind turbine in Denmark. There were machines before on a commercial. In 1978, twin machine was, of course, a strong private initiative and symbol not just for Denmark, but at least for Europe as well. And Twinkraft, the twin turbine, had an enormous influence on the entire wind development in Denmark. In the same year, another very important step occurred. The first wind turbine with federal approval by federal approval agency Riese appeared. That was a 15 kilowatt machine made by the company Adolfsen. Adolfsen did not become a big player in the Danish industry, but at least it was another pioneer. And that company at least managed to get a federal approval. Why this federal approval? If a turbine was federally approved, it was eligible for federal subsidy, and it was easier to market this machine in Denmark. because of trust, because of technical reliability, etc. 1978, another big year. Vestas gets involved in wind energy. They had some experiments going on with a B-blade W wind turbine. We will later see Vestas' very first horizontal axis machine. 79, the first federal subsidy program was commenced with 30% of state subsidy for each wind turbine that someone was interested to purchase, which was quite a lot. That figure dropped to 15% in 1985 because wind turbines became more reliable, more economic, and bigger. Let's look at wind. What the Twin people did was more than impressive. We can see here some pictures of the entire manufacturing process, starting with blade manufacture on the upper left side, blade transport on the upper right side, the building of the nacelle structure, various components being lifted on concrete tower, with the turbine to be finally inaugurated in, I think it was February or March 1978. What these people did was a very brave, courageous thing. They had no federal support. They did not really have support from the industry. The industry was on a very small level at the same time. Anyway, they managed to realize this machine. Before the large twin turbine was built, they had built a smaller 22 kilowatt turbine, which is a fact that many people don't know. But the big twin turbine was not number one, it was actually number two. A lot of technical experience was gained from that first little 22 kilowatt machine, so the bigger machine was easier to set up. So here's a shot from early 1978, the final steps of the installation of that turbine. And I have to say, I was there for a couple of times, and it's still today, this is more than an impressive achievement. It is a more or less magic moment standing under this machine. So here is a 6x6 black and white shot of August 2019 that I have made. That's how the turbine looks like today. As you can see, the turbine was painted red and white, not in the black and white shot, but it is red and white, standing for the color of the Danish flag, so-called Dannebrog. The blades of this turbine were changed in 1993, and you never guess who made these blades. It was Vestas, in recognition of the accomplishment of what the Twin people did. And that was quite a lot. Another shot, 6x7 black and white shot of Riesager turbine, which is installed here at the Museum, the Electricity Museum that we had already been talking about last year, I think. They were in financial troubles. But anyway, this is just to give you an impression of what typical Riesager machine from 1970s looked like. So we have a lattice tower, we have 3 blades in the upwind position, we have wires to stabilize the rotor, we have these little tail vents in the back. This is to mechanically yaw the machine. This machine had almost no electronics or digital devices. It was fully mechanic. It was work. The Riesagers were considered good, but not very good. There were a number of other companies following this technical concept. For example, Windmatic, who in the 80s became one of the big 5 companies. But anyway, this is what a Riesager looked like. And just to give you a short impression of this. So here we have a truly iconic moment in whole wind power history. Installation of the very first horizontal Vestas in 1979 in Lem, directly at the factory, which has turned out a giant village, kind of village today. In 79, it was almost forgettable. A horizontal axis 55 kilowatt machine on a lattice tower. Note the fact that almost the entire machine was pre-assembled on the ground and then lifted in one piece on the lattice tower. We have a 3-blader upwind position. In this case, active yawing, strong and overall strong and stiff construction, the total opposite of the American approach, which was lightweight helicopter technology. The Danes did the complete opposite. And Vestas followed this technical concept until 87, 88, when they introduced the pitch machine. This is a stall regulated machine. In 87, they introduced a 200 kilowatt pitch regulated machine, which had a significant change in their concept. But that's the main concept Vestas had followed for several years, and they were extremely, extremely successful with this way of doing it. Here's some figures for you. I would like to stress the period from 76 to 78. Danish Ministry of Energy. 50 machines in the first part, 120 machines in the second part, with an accumulated capacity of around 4 megawatt. 170 machines. Some say it was 200 and more, depending on the source. Anyway, this is a good proof to show that Denmark, along with the states, had a strong activity back in the 70s already. Another very important figure we can see here is the one starting in 1982, 50 machines exported, 360, 1,600, 3 and 2,000. That was the huge California wind rush, which we'll look at later on. Just to see the importance of Danes, 2,000 billion Danish kroner, which is like 2 billion at turnover, which is massive, just as been unprecedented as ever before. It was a giant achievement they had. So let's look at the 80s. Denmark and the US are still leading, still the top countries that everybody visited, everybody wanted to look at and hear about. The Netherlands became another significant country in Europe to apply wind energy. Starting in 83, 84, they had another federal support program for wind energy, but the Netherlands did not reach the level of Denmark and not at all the level of the US. 1980s was the decade of first commercial mass application of wind turbines, especially in Denmark and the US. Parallel to commercial development, there were a rising number of research projects across Europe, Sweden, Germany, also Denmark, the United Kingdom, of course, and the Netherlands and some others started building research turbines to gather more technical experience in wind turbine technology and also to establish their own wind industry. 1980s saw a continuous and very fast-paced development internationally, which will continue through the entire 1990s. Let's look at the standard size of wind turbines in Denmark, which were technically considered the best in the world. 1980, 22 to 55 kilowatt was typical size, applied as single turbines, cluster, 3 to 4 machines, and larger wind farms. In 1985, they had reached almost 100 kilowatt, which is almost twice the size. That was a huge achievement at the time and a huge risk for the companies to take. In 1989, they had achieved the famous class of 250 and 300 kilowatt, which again was a huge achievement, but it showed how fast the technical development of wind turbines in the 80s already was, not just today, but already at that time. Wind turbine technology has always been super fast-paced and super competitive. Denmark saw a rising market with numerous manufacturers and various organizations. They had a 30% subsidy on the purchase of wind turbines since 1980, what I've already mentioned. In 1982, exports to California started. The first two companies to export wind machines were Vestas and Bonus. Vestas sent two 65 kilowatt machines to Altamont Pass, which is the largest area of wind development in the north part of California. Bonus had sent like 3, 4, or 5 machines to Tehachapi to an operator called Oak Creek Energy Systems, OCES, which was a major player in Tehachapi wind development. In 1983, the first official wind farm on the island of Farne was inaugurated, comprising 10, 11 Vestas 55 kilowatt machines. The same year, our friend Oelker Center was founded. Very important to mention as well. 1985, Denmark was hugely involved in the California wind rush, peak of 3,000 units. Imagine 3,000 units, which the world had never seen before. In 85, giant achievement. In 1989, Denmark itself had 2,500 wind turbines across the entire country. And they also managed to include the bigger utilities to develop their own bigger wind farms. It was not just private companies and single individuals, but also bigger utilities like Westkraft, Nordkraft, SEAS, or Südkraft. Development of wind energy in Denmark, 76 to 86. Just another graph to give you an impression of what happened at this time. The super fast-paced, very impressive development the Danes had achieved. If we look at the bar on the very left, 76 to 79, this bar tells us it was about 250 machines. The other graph said 170. Well, nobody really knows, but at least it demonstrates the Danes had a serious development in the 70s already. Here in 85, 86, we had December 86, we had about 1,600 units comprising 80 megawatt, which was a giant achievement at the time. Today, 80 megawatt is like nothing. Back in the 80s, it was everything. Danish export of windmills, just to give you another impression of the importance of the Danes, starting in 82 and peaking in 85 with approximately 3,000 units sent to Altamont Pass, Tehachapi Pass, and Palm Springs and Gujoni. Here's another example what Denmark looked like back in the 80s, around 1986. We have various wind farms, Bonus, Vestas, Windmatic, and Nordtank. The upper part is Oddesund Nord, very closely located to the Folker Center at the time. The wind farm disappeared, but it was close to the center. On the upper side, we have Ærø, which is Vestas, Oddesund Syd, which is a Bonus, and again, very closely located to the Folker Center. When you were riding with this train here, you went through the entire wind farm and you had 3-leg Bonus machines on the left and the right-hand side. Then you went over to the bridge, and on the left side was Oddesund Nord, and 10 minutes later you arrived at Ydby, Sønder Ydby, where Folker Center is located. Here we have Denmark's first wind farm, 83, Farnø, in the south of Denmark, south of Esbjerg. Lower right-hand side, we have another interesting example of early wind development. The world company IKEA, it is the IKEA that we all know. IKEA developed a small wind farm in 84, very close to Copenhagen, comprising 3 Windmatics. Windmatic was one of the big 5 players. 3 Windmatics of each 55 kilowatt. IKEA Windmøller, it was called. On the lower middle part, we have the very famous Ebeltoft wind farm. Same here, offshore wind farm, 1985, 16 machines, Nordtank 55 kilowatt. We will have a look at this one later on. Lower left side, we have the federal, more or less, research wind farm, comprising 5 wind turbines on the 750 kilowatt range, which was way too big at the time. So it was more kind of a development or research wind farm. These turbines were built by Danish Wind Technology, which Danish Wind Technology was not a typical Danish wind company, but more a kind of exotic appearance, more or less. They played their own part, their own role. The final wind farm here in the middle left side is Southwest Mors. Mors is an island north of the Folker Center, 10 times Vestas 75 kilowatt. Folker Center was involved in the planning and location of this wind farm. Once again, the famous semi-offshore Ebeltoft wind farm, a shot that I had made summer 2001, and these old turbines were still up. They disappeared 1.5 years later. There's been a lot of discussion in the industry whether this is an offshore application or not. In my view, it is a so-called semi-offshore application because the wind turbines are still closely located to the shore, and there is a connection, a land side connection. Anyway, this wind farm was super famous, was a typical symbol for Denmark's rise in wind energy, for Denmark as a wind energy icon itself. And by the way, very beautifully integrated into the landscape. A typical Danish scenery, look at the boats here, people walking around, no fences, no anything, just the wind turbines and the landscape and the people having fun. Oelker Center around 1986, the famous test site. This is just to give you an example what Oelker Center looked like back in the 80s. This machine here on the right-hand side is still working with different blades. The other machines are now in the museum store. This is the test site, which is still running until today. I don't know if it's running right now, but anyway, Oelker Center played a major part in the development of wind turbines in Denmark as well. It's not just Vestas, Nortag or Balkan, but Oelker Center too. The US in the 80s, everything about California. California becomes the world leader in wind energy within a few years because of so-called tax credits that enabled a giant and super fast-paced and super competitive market since 1981. In 89-90, approximately 17,000 units had been set up. Some sources say 15, others say 20. It was so dynamic. It was kind of Wild West mentality. No one really knows. I have chosen the figure of 17,000 just to give you an impression what California was like at that time and what Americans had achieved at that time. Consequently, there was no comparable event in wind energy ever before. And, which is most important, California's wind farms proved three very important facts, very important messages that were sent out to the world. Number one, wind energy can be applied on a large scale. That was not for granted. That was the first time it was simply done. Second, wind energy can be economic and sustainable at the same time. That was something that many people questioned. Californians proved it was possible. Wind energy can compete with conventional energy sources. Very important message. In 85, 86, about 1,500 megawatts were installed, comparable to a conventional nuclear power plant of the time. And that was an achievement no one else had in the whole decade. California was everything. Wind system installations in the United States from California Energy Commission. This is just to give you another graph to show how quickly the installation figure, the number of turbines and the capacity factors rose just within a few years. Some companies did not manage to compete with this speed on the American side and on the European side. But anyway, wind energy had achieved a new level of size, and that was just perfect. This is a chart I had made in September 2010. We are now looking at some pictures to give you an impression of what this wind rush in practice looked like. Enertech E44, the 40 kilowatt machine. That's a company I had talking about before. That started in the 70s. In the early 80s, they had a 40 kilowatt reliable wind machine. They sold more than 400 machines to the California wind rush. Thus, Enertech played a very significant role. It is a downwind machine, lightweight construction, and tip spoilers. When I was at Altamont in 2010, almost all of these turbines were working. That was a wind farm complex of 144 machines. When I took this picture, not all of them were working. The day later, I made a flight over the entire Altamont Pass, and almost all of the Enertechs were working. They were installed in 83, and they were still operative in September 2010, which is indeed a huge achievement. Flow wind vertical axis wind turbines, Altamont Pass in mid-85. When I was there, flow winds were already gone, unfortunately. In the end, they failed. The technical concept failed, but Altamont and THP together had about 500 vertical axis wind turbines. Flowwind was a company who commercialized these vertical axis machines developed by DAF and Sandia in the 70s, what we had seen before. Yeah, this is a 6x12 negative shot of the extremely famous wind wall, which was an array of 400 Vestas 90 kilowatt machines and THP parts. This wind farm became iconic on the entire globe for the achievements Americans, especially Californians, had made in the 80s. It became a symbol for successful application, large-scale application for wind energy. The entire site here was developed by Zond, which was a very big California wind developer that our friend Paul Geib had also been working for. So when I stood in front of this wind farm, it was not just impressive, it was very, very windy as well. So you can see in the lower right-hand side, there is an exposure failure on the negative. I hope you won't mind. Yeah.
It's very exciting, but just looking at the time, if you can try
at the time, I will speed up. I speed up.
Yes,
okay. I speed up. Here are some more shots from THP, aerial shots, and some a shot of Micon turbines, Mitsubishi, array of 660 machines, another shot of the famous wind wall, this time in color, and the German Aeroman machines still working more or less in 2010. San Gorgonio Pass at Palm Springs, another huge large-scale array along Interstate 10. A mix of American Enertex on the left and Micon 6065 and 108 kilowatt. Another shot of the famous Victory Garden wind farm operated and developed by Zond and THP. We have a mix of Vestas here in the back, American Stormmasters ESI on the left, and in the middle, Dutch Polenco machines with metal blades. Paul created this chart in 1991, telling the entire story about the 1980s. The US were the dominant nation all over. This is a wind generation in 1,000 megawatt hours. So California and Hawaii had a super strong position on the entire globe. Denmark followed, the Netherlands just a little bit, and everything else, everyone else, Germany, India, China, and whatever, remained under the term other of 120, which is like nothing. Let's have a quick look at the 90s. 90s were considered as a global breakthrough of wind energy on the entire globe and the entry into the megawatt class. Fast-paced, even more dynamic and super highly competitive development in markets. Denmark and the US retain their relevance in general, but Germany becomes a new leader in installed capacity and was on global #1 in 1999. Other Europeans followed, Spain, UK, and Netherlands. 1993, we had a first commercial 1 megawatt turbine available by Dutch Netwind. They were the first to introduce serial megawatt turbines. 1999, Nordics introduced a prototype of 2.5 megawatt installed at the famous test site at Grevenbroich. I was there in January 2000. Very impressive machine. Europe as a whole became the mecca, or the new mecca of wind energy, parallel to the US, and we had a slight shift in technological progress and installed capacity from the US to Europe. In the US, California remained on top, plus new projects. Other states like Minnesota and Iowa followed. On the US side, we had two American companies, Zond, the former wind developer, turned into developer of wind turbines and manufacturer of wind turbines. Kenetec, the former US Windpower, realized huge projects as well. They had machines between 100 and 400 kilowatt. Foreign companies in the 90s in the US were especially Mitsubishi, Vestas, and NEG Micon, the merger of Nortank and Micon. Denmark in the 90s, still technologically leading. In the mid-90s, strong dominance of the 500 kilowatt, 600 kilowatt class and 250. 1991, world's first real offshore wind farm at Vindeby. Since 1995, the Danes managed to develop, produce megawatt turbines. Vestas, Micon, Nortank, Walnut Nordics were typical names. Typical size from 1 to 1.5 megawatt. The Danes had a very strong position internationally, especially in Germany, in India, the UK, and later the Netherlands, and of course the US. And the famous blade producer LM becomes #1 on the globe. Here's a short picture of Windpower from 1991, 11 bonus machines, which is Siemens today, of the 450 kilowatt machine with 35 meters in rotor diameter. They later had a 37 meter. That was a different machine. Typical superstar of 1990s, the Vestas 1.5 megawatt installed at Tierburg Enge, 1996. Big achievement for Vestas, and just a proof that the Danes still were leading technologically. Germany, the new superstar in the 90s. We saw in 1989 the first wind fair at Husum, which was called Husumer Windenergietage at the time. 1991, the famous Stromeinspeisungsgesetz, Electricity Feed-in Act, something like this, which was a legal basis for the massive boom that most of us know during the whole 1990s in Germany. 92 was a revolutionary year. Enercon installed its first gearless turbine, 450 kilowatt machine. Germany turned the new leader in Europe regarding installed capacity in the late 90s. Nevertheless, the Danes had a super strong position in the German market. At least 50% of all German projects were realized with Danish wind turbines. We had two big rivaling companies, I stress rival companies, which is super famous Enercon and the almost forgotten Tacke. Back in the 90s, these were the two superstars Germany had to offer. This is an example for Tacke, famous 600 kilowatt machine. I made this aerial shot in April 2009. It was Europe's biggest wind farm for a short period in the mid-90s and a strong symbol for the German application of wind power and for the success of Tacke as well. Enercon's ever first gearless wind turbine, 1992, Enercon 36, just a prototype, not a serial machine, only a prototype, 450 kilowatts. So you can see the gearless construction, the gearless design very clearly. They later had a more elegant design. This was just to mention, this was Enercon's very first approach to gearless ring generator technology. I thought it was interesting to have a look at it. There was only one E36. The E40 was a successor, and that's what everybody knows made Enercon succeed in the whole world. Let's have a final look at this. Windpower Museum published this chart in January 2000, and it roughly tells the entire story of the 90s. Europe, Germany was on top with almost 4,000 megawatt. Denmark was behind at 1.7. Spain made a huge development as well, just like the Netherlands, the UK, Italy, and Sweden, but Germany was unrivaled. South Central America at the time, forgettable. Canada, a little bit here, a little bit there. India was another superstar, 1,000 megawatt, and then look at China, 182 or 225. I think they skipped these figures here. Anyway, 224 megawatt in 99 is like nothing compared to today. China was a nobody in the 90s, not today, in the 90s. Pacific region, Japan, Mitsubishi played no role, forgettable, just like Middle East and Africa. California still on top within the US and on the world as well. Plus Minnesota, Iowa, and Texas having their own successful developments. And that's it. Thank you.
Thank you very much, Arne. And again, I mean, we know that you could spend, and it's still very interesting, spend hours and days.
It's the Mount Everest. 70s, 80s, 90s, the Mount Everest of wind energy.
Yes, I think we should, with the three speakers we've listened to, we can fill a semester of lessons at the university about
stories. Yeah.
History of, yes. Really fantastic. So I'm looking now whether there is anyone who would like to comment, maybe even add something, anything that has not been mentioned, or just would like to say anything. I mean, we're really also the guests that we have here, people from all over the world, from all continents. Do we have any comments now?
Stefan, can you hear me? It's
Yes,
Peter Ray.
Peter from Australia, huh?
I thought I'd just like to add to what Elizabeth told us, what might be interesting, and that is that Australia was developing, as was the United States, wind turbines for pumping water. And this took place in quite large quantities in the middle of the 1800s. And by 1871, in Australia, there was a fairly significant manufacturing industry of wind turbines for providing water from the artesian basin, the underground basin. So it was pumped up. It was also used a lot for pumping water from rivers. And in fact, I grew up in a place where next door to the house was a wind turbine, which has encouraged me to be involved with wind turbines ever since. And it was for pumping from the river. And I won't take a long time about it, but I just wanted to mention that because it may be relevant to add to what Elizabeth had for her part of the operation. As you know, we've gone on to wind turbines for energy and picked up quite a long way since the late 1990s and into the current century. Thank you very much to those people who have provided the information. And I must say I found it extremely interesting, and thank you very much for all of that presentation.
Thanks, Peter. I think that is a very important statement, of course. We're indeed, as you rightly said, we're now focusing on the electrical use or producing electricity, but there's other ways of using wind power as well. Now, I would like to give the floor to Kolya because we agreed, Kolya, at least for a couple of minutes to present our efforts, our activities. We're trying to not only speak about what we can read somewhere, but also to maintain and keep and coordinate keeping the archives and the records. Kolya, can I hand over to you?
Thanks. I don't have a presentation. I'm just going to sort of piece together some things both from this webinar and the work we're doing. So first of all, I think this webinar is sort of really a coming of age of our slow work over the last 2 to 3 years on archives, because this webinar is bringing together wind energy practitioners, historians, archivists, people from museums, journalists, photographers, and from many different countries that show the global nature of the process. So I think this is a very sort of good moment in this. I also think that I want to say that this webinar shows the importance of archives. It shows that you cannot preserve your history if you don't have your archives, and you cannot interpret your history if you don't have your archives. So this itself shows, you know, the importance, and clearly the presentations have drawn on a very, very rich array of archives, both from countries people are from, but also from many, many other countries and many other periods. The webinar has shown the different kinds of archives that are available. So the question of pioneer archives, very much personal archives that Liz presented, the question of forgotten countries, in recent years, the contemporary world does not talk much about the Soviet Union, Eastern Germany. The contradictory nature of things, the not necessarily pleasant findings. We think today of wind energy as a progressive technology. And then Jan tells us about how the Nazis used wind energy, how it was part of their occupational plans. So, you know, we need to unpack the complexities of history. We also see the things like the connection between oil and wind. We think of them now as very separate processes, but we hear from Jan about the Baku oil industry being used with wind energy. So that's a very interesting thing. But a big thing that I think we need to think about is that preserving records doesn't happen automatically. Records are very different from published library material. Records are evidence of actual events, actual actors, actual places, actual projects, and they do not get preserved automatically. It takes very deliberate efforts. It takes planning. It takes resources. It takes skills. It takes money. It takes knowledge of the sector itself to know, who the key actors, key periods, key projects were. So we've been looking at how to do this, and we've developed an approach based on the World Wind Energy Association and the Mills Archive as two leading practitioners. The World Wind Energy Association is one of the very significant global organizations in the wind sector, and the Mills Archive is a significant organization in preserving the history of wind and the actual records. We've, over the last few years, developed a framework and a methodology for thinking about this, and we presented our ideas in a number of forums, particularly in archival landscapes, in the International Council on Archive, the Business Archives Council in Britain, and the Archives and Records Association in Britain. And we've also had a parallel process through the World Wind Energy Association of a number of webinars relating to wind energy history. And this has recently taken a step forward with the project that Liz talked about, the Mills to Megawatts, where we've attempted a kind of survey of what records exist in Europe. This is obviously a very big project and is not just a European project. It needs a global dimension, but for limitations of time and money, we focused on some of the European countries where there's been important processes in wind. And we did a pilot project that basically looked at 3 different categories of institutions where wind energy archives may be found. They may be found in national archives. They may be found with institutions that are specialized in wind energy history and preserving it, such as the Mills Archive or the German Windpower Museum, where we went to during this project. Or they may also exist with the wind energy actors themselves, such as companies and pioneers. We're well aware that there are many other kind of archival institutions that will also hold wind energy records, such as local archives of municipalities where there are wind projects or wind companies, or science, technology, and engineering institutions. However, we didn't have the possibility to approach them at this stage, and we're hoping to in the future. We've made some interesting contacts through this process to such institutions. And we're still writing up the results of this project, but what some initial findings are that many of the key collections and specialist knowledge are in a small handful of institutions that are very deliberately protecting the history, such as the Mills Archive, the Oelker Museum, the Oelker Center, the German Windpower Museum. And these also often have museum collections, quite interesting, physical artifacts that are also a record, whether it's the actual equipment, whether it's offices, former laboratories, different things. So not just the sort of conventional documental archival evidence. So that's one layer. The other layer is national archival collections. This is quite an interesting one because most national governments will not be mandated to collect things such as wind energy records. Their business is to collect the archives of state. And most countries, wind energy doesn't play a phenomenally important role. So, the collections relating to wind energy will be held incidentally in national archives, such as in the Ministry of Electricity, or, countries where there's been a state involvement in the wind sector, this is likely to be important. So I was very interested to hear about the role of the federal wind energy programs in the US in the 70s, because this means that will be likely to be archived in the national archives. They have the resources, the national archives, but they don't necessarily have specialist collections on wind energy. The institutions specialized in collecting wind energy history often don't have the necessary resources. Often they have grassroots approaches. They have the subject expertise, but not necessarily the expertise in handling archival and museum objects, often have to chase up money through quite difficult processes of fundraising. So it's different layers. And then the question of the wind energy actors is also very interesting, because for the most part, these are not yet archived in formal archival institutions. And as such, they're quite at risk. They're in the hands of individuals in their homes, which may, people may move, they may have to go to smaller places. They're in the hands of organizations, and organizations don't necessarily survive. There are many of the pioneering organizations we heard about no longer exist. So the question of what happened with their archives is one that needs investigating. In a way, the older material is much safer. Stuff from the late 1800s, early 1900s will either be in an archive or it won't. It's unlikely to suddenly find its way to an archive. The main danger for that material is that it's been forgotten. So the question now is, how do we raise awareness about it? How do we actually seriously research the contents of those records? But the question of 1970s, 1980s, 1990s that Arne just talked about is in a way the most vulnerable period, because that's the period that until recently was the present day. And it was currently existing actors, people who are still alive, organizations that still exist. And suddenly that period is actually quite distant history. So there's actually sort of more vulnerability in many ways. This is not even talking about the changes of technologies from paper to digital records that happened in a similar period. You think how vulnerable floppy disks from the 1980s are and how difficult it is, and that many of them have been thrown away. So there's different challenges for the different periods. We're very much seeing this as a work in progress, and we're very much seeing it as a project that needs collaboration, because the expertise is in different hands and the records are in different hands. And it's not practical to try and build one global central archive where the records will be held. That's neither practical nor desirable. And the question then becomes, how can we have a network process? How can we gather information and share information? So this map that the Mills Archive is building, that Liz talked about, can potentially be very important to not just highlight the stories and the actors, but actually the collections, where archival collections exist. We're still very much working on that. We would very much like to hear from people who know about the existence of archives, either in individual hands or organizational hands, or in archival institutions, so that we can actually get a lay of the land and understanding of this. I'm very pleased to see that many people on this webinar are people who I've made contact to through this questionnaire, this survey, looking at wind energy archives. And there's actually more than we're expecting, I think. It is there, it's hidden, it's, it needs drawing attention to. There is there material. There's also material that's not there, that, and that needs protecting. And that's, I think, something to think of. We're doing this in a process that, let's say, it moves at the pace that the resources allow. It's a complicated process to try and get resources for. We're looking at possibilities for discussing and developing this work further in the World Wind Energy Association Congress that's coming later in this year in China. We do not know if this will happen or not yet, but we're considering possibilities for that. And the idea of really linking with the actors in the wind sector is a very important part of this process, because that's where the records are, many of the records. And yeah, that's pretty much sort of what I would like to say on these issues.
Great. Thanks a lot, Kolya. I believe that summarizes or kind of concludes a little bit. Before you have seen the different periods of wind power, how modern wind power started, how it evolved, became the technology where we are today. And now you also know we are doing this all as part of the project. We want to preserve as much as possible for future generations. I mean, I think all of us, we know some people, let's mention, like Megard, who's passed away already. And that is always a loss, of course, for the future. Yeah, with this, I would say thank you very much. You have heard that we are open. This is not kind of yet a formalized way. If anyone is interested, is aware of any records, anything, contact us. We're happy to talk with you and see how we can collaborate. And as Kolya also mentioned, of course, we're also trying to raise additional funds in addition to the first project that we mentioned. Does anyone want to say any kind of words before we conclude our meeting today? Paul, please.
I just wanted to thank everybody for their presentations. I've been doing this for a long time, working with wind energy, and it's still fascinating. And thank you for your presentations. Very interesting material, and thank you, Stefan, for pulling us together, and Liz. Thank you very much.
Thanks a lot, Paul. And that, I think, is especially appreciated, as everybody here knows that you've done so much work on this. Thanks a lot, I think, to you. Here, our speakers refer to your work as well. You know, because you also done a lot of work just on your own, how demanding it is. We're trying to continue this work, looking forward to staying in contact with you. And with this, I'd like to say thank you to everyone. Actually, I should mention everyone here personally, but time is over. So thank you everyone for joining us, and we look forward to staying in contact.
Okay.
Thank you.
I will say special thanks to Jos Borskins to give me the pictures from Russia. This was really they lay in my on the desk since years, and now it was time to look for this as well. It's a great treasure. Thank you. And Paul, that you are healthy, this is also good to see. We a long time not seen personally. Bye. Thank you.
You will be able to watch this again. If you want to see certain pictures, of course, you can refer to our speakers as well. This webinar will be available in our YouTube channel, and I expect that we will do that later today. Thank you. Have a good day, and goodbye.